Hello, welcome back to Educator.com and welcome back to AP Calculus. So today we're going to continue our discussion of ways of taking the derivative of different types of functions very quickly. So we're going to discuss the product rule, the power rule, and the quotient rule for functions. So let's jump right on in. Okay, so here's what we've got. What do we do? You know what? I think today I'm going to work in black. So what do we do when we have to differentiate functions that look like this? Differentiate functions like the following. Let's say we have f of x is equal to 2x squared minus 1 cubed times 3x minus 4 to the minus third power. How do we differentiate something like that? Or what if we had f of x equals x squared times the sine of x? Or what if we had f of x equals 2x squared plus 3x plus 2 over x squared minus 6? How do we differentiate that? Or f of x equals 3x squared plus 1 to the fifth power. How do we deal with these? Okay. Now, in the first and second cases, in other words, this one and this one, what we have is our function capital F of x is actually a product of two separate functions of x. So, first case, f of x is a product of two independent functions of x. Independent functions of x. In other words, we have, let me go to red here, we have this is one function, the 2x squared minus 1 cubed, and this 3x minus 4 to the negative 3 is a separate function. In this case, we have x squared, which is an entirely separate function of x, and sine x, which is an entirely separate function of x, but they're multiplied together. How do we take the derivative of something like that? In the third case, we have an independent function of x divided by an independent function of x. And in this one over here, we have some independent function of x, and it's actually raised to a power. We actually have the same case here. This whole thing is an independent function of x. It's actually made up of a function of x which is raised to a power times a function of x raised to a power. How do we handle things like this? Okay. Now, you might think to yourself, well, if f is the product of two functions, if I take the derivative of f, isn't it just the product of the derivatives? In other words, why can't I just take the derivative of x squared multiplied by the derivative of sine x? Turns out that that's actually not how it happens. So, now let me write this down. You might think that if f of x equals f of x times g of x, then f prime of x equals f prime of x times g prime of x. This is not true. Absolutely not true. It's true that the derivative of a sum is the sum of the derivatives, but the derivative of a product of two functions is not the product of the derivatives. It also isn't true that the derivative of a quotient of two functions is equal to the quotient of the derivatives. So the derivative of f over g does not equal f prime over g prime. Here are the rules for handling products of functions, powers of functions, and quotients of functions. So let's go ahead and go through these. So the product rule, you know what, I think I'm going to go back to black here. So our product rule. Product rule is, so if f of x and g of x are differentiable, and again, our presumption all in the entire calculus course is that they're going to be differentiable, then the derivative of fg is equal to the derivative of f times g plus f times the derivative of g. In other words, the derivative of this times this plus the derivative of this times this. You can keep them in order. Essentially what you're doing is you're just taking the derivative of one function at a time as you go down. So this is the shorthand notation. The derivative of a product is f prime times the other function plus f times g prime, the derivative of the other function. Now, this can be extended. This can be extended to a product of 3 or more functions. Extended. I tell you what, why don't I actually write a little bit better here? This can be extended to a product of 3 or more functions. And that's going to look like this. The derivative, well, let's go ahead and write. So let f1, f2, all the way to f sub n, whatever n happens to be, 5, 10, 15, 20, however many functions, f sub n, let them be n differentiable functions. Then, the derivative of f1 times f2 times all the way to fn equals f1 prime times f2 times all of the functions plus f1 times f2 prime times f3 times all of the functions plus f1, f2, all the way to fn minus 1, fn prime. Basically, all I'm doing is I'm leaving the functions as is, and I'm just taking the derivative of the first function, and then I take the derivative of the second function, multiply it all out, and the derivative of the third function, multiply it all out, until I've taken the derivative of every single individual function, and then of course I'm adding them. Most of the time we're just going to be dealing with 2 functions, so this one right here is sufficient. That's the product rule. That's how you handle taking the derivative of a product of 2 functions. So really what you have to do is just recognize which 2 functions you're dealing with. What is f and what is g? And again, all of this will make perfect sense once we actually see the examples. So now let's talk about the quotient rule. As we said, the derivative of a quotient of 2 functions is not the quotient of the derivatives. The quotient rule is the following. d dx of f over g is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over g squared. F and g are functions, okay? These are actual functions. Oh, excuse me. And now let's go ahead and finish off with the power rule. Now, I'm going to use u instead of f or g. So let u be differentiable. So in other words, u of x is an actual full function of x. Okay, let u of x be differentiable. The derivative of u to the x raised to some power, any real number, it's equal to, it's handled the same way as a function of x. It's n times the function, the exponent n minus 1, and then I'm going to multiply by du dx. Okay, let's talk about what this actually looks like. Before, we dealt with something like this. We said x to the 5th power, okay? When I took the derivative of that, we ended up with 5x to the 4th, right? We took this, brought it down, subtracted by 1. Now, x is the function. It's raised, it's the variable. It's raised to the 5th power. Now what we're saying is if you have something like this, if you have 2x squared plus 1 to the 5th power, now this is your u of x. It's an entire function that contains x. It itself is raised to a power. When you take the derivative of this, you treat it the same way. It's still going to be 5 times 2x squared plus 1 to the 4th, except you have to multiply by the function itself, by the derivative of the function itself. du dx. In this particular case, the du dx, the derivative of what's inside is well, you know what, that's fine, du dx. And this ends up equaling 5 times 2x squared plus 1 to the 4th power. The derivative of that is 4x. So it's just that extra step. When the thing that you're actually raising to a power is a full function of x, you have to take the derivative of that function. It's actually the same thing here. Really what we're doing here, it's actually a special case of this. X to the 5th, well, when you take the derivative of this, what you're doing is you're doing 5x to the 4th. Well, this is your function of x. So you're taking dx of dx. Well, dx over dx is just 1. So it stays 5x to the 4th. You're still doing the same thing, except your function of x just happens to be x alone. It is the variable itself. There's nothing else going on there. So in any case, I won't belabor the point here. It'll make a lot more sense when we actually do the example problems. All you have to remember is once you identify some function that's being raised to a power, you do everything the same way. You do the power part, and then you just remember to multiply by the derivative of the original function itself. Okay. So let's go ahead and get started with our examples. Y equals x squared plus 4 times x to the 4th plus 8. Find dy dx. Okay, so there's a couple of ways that we can do this, and that's what's sort of nice, that now you have multiple paths that you can follow. Do I do the product rule? Do I multiply it out and just do the normal the derivative of each individual term because this is a polynomial? If you want, you can just, multiply this times that, this times that, this times that, this times that, and then take the derivative, or you can treat it like a power rule. A product rule. Let's go ahead and do it as a product rule. So this is our f, and this is our g. Well, the product rule says, that y prime is equal to f prime times g plus f times g prime. Well, let's go ahead and do that. Y prime equals f prime times g. Well, f prime, the derivative of this is 2x times g. g is x to the 4th plus 8. We leave g alone. Now we leave f alone, so we write x squared plus 4, and we do g prime. Well, this is 4x cubed. That's it. You can just leave it like this if you want to. I mean, it's perfectly valid. Or again, depending on what it is that your teacher or professor wants, you can multiply it out. So if you want to multiply it out, this is just going to be y prime equals 2x to the 5th plus 16x plus 4x to the 5th plus 16x cubed. 2x to the 5th plus 4x to the 5th, y prime equals 6x to the 5th plus 16x cubed. I'll do it in descending powers of x plus 16x. There you go. That's it. Nice and simple. Product rule. F prime times g plus f times g prime. All you have to do is recognize what the f and the g are. That's going to be your only task. Okay. Y equals x plus 1 over x minus 1. Okay, this one, so we have f here, and we have g here. You know what, I think I'm going to go ahead and do this in red. So this is going to be quotient rule. So the quotient rule says that y prime is equal to, okay, g, this is f, this is g. g f prime minus f g prime over g squared. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. All right, let's just do it. So y equals g, which is x minus 1, times the derivative of the numerator, which is 1, minus f, which is x plus 1, times the derivative of the denominator, which is 1. The derivative of x minus 1 is 1. All over the denominator squared. X minus 1 squared. Okay. Well, if I distribute the negative sign, on top I get x minus 1 minus x minus 1 all over x minus 1 squared. X cancels. I'm left with minus 2 over x minus 1 squared. That is my y prime. That is my dy dx. At a given point, x, if I choose a point, and if I put it in here, this is going to be the slope of my tangent line to that curve. This represents the rate of change. For a unit change, for a small change I make in x, y at that point changes by that much. Rate of change, slope. Okay, let's try this one. So we have this thing raised to the 5th power. So in this particular case, this is going to be our u of x, and it's a whole function raised to the 5th power. So we're going to use our power rule. Our power rule. So we have, our power rule says f raised to the 5th power equals 5 times f raised to the 4th power times f prime. Okay, well, let's go ahead and do it. So y prime equals, that comes down, 5 times, I leave that alone, 4x cubed minus 3x squared plus 6x plus 9 to the 4th power times the derivative, times f prime. Now I take the derivative of what's inside, times 12x squared minus 6x plus 6. I'm done. I'm not going to simplify this anymore. I'm not going to multiply it out. That's it. I'm done. I just have to run through the rule. Nice and straightforward. Example number 4. Okay. Y equals 5 over 3x minus 5 to the 4th. Okay, well, it is a quotient in the sense that you have 5 over that. So you can certainly use the quotient rule. Another way to handle this is actually doing just the power rule, believe it or not, because I can actually write this as 5 times 3x minus 5 to the minus 4th power. So you have multiple paths that you can take. You can do quotient rule or you can do power rule. And it's always going to be the case like this with problems like this. You're going to have a choice. And the choice doesn't matter. Sometimes it's the same amount of effort, no matter you go to this path, this path. Sometimes one of them is going to be a lot quicker than the other. Sometimes one of them is going to be messy. The other one is not going to be so messy. It just depends. And it's just a question of experience as to, which one is going to be better. Oftentimes, you don't know which one is going to be better. You just have to jump in, go down a path. If it starts to look too complicated, well, you change paths and you go down another path. Very, very simple. Okay, so let's go ahead and do y prime here. So y prime equals 5. This is a constant. This is going to be, I'm going to bring this down. This is going to be minus 4 times 3x minus 5. And then I'm going to take the derivative of this. Oops, to the minus 4. Minus 4 minus 1 to the minus 5 power times the derivative of this, which is 3. So y prime is equal to, let me actually do it over here because I'm going to need some room. So 5 times negative 4 is negative 60. Negative 60 times 3. 5 times negative 4 is negative 20. Negative 20 times 3 is negative 60. Let's not jump the gun here. Negative 60 times 3x minus 5 to the negative 5th. This is our answer. Okay, let's also do this via the quotient rule to see what it looks like. Let's also do this via the quotient rule. Well, y prime, so remember what we said the quotient rule is. It is, so if this is f and this is g, it is g f prime minus f g prime over g squared. So y prime equals this, 3x minus 5 to the 4th times the derivative of that, f prime, which is 0, minus 5 times g prime, the denominator, times the derivative of this, which is the derivative of the denominator, which is 4, times 3x minus 5 to the 3rd power. 4 minus 1 is 3, times the derivative of what's inside, which is 3. All over this squared, 3x minus 5 to the 8th power. Well, this is equal to, so this is just 0, so we have minus 60 to the times 3x minus 5 cubed over 3x minus 5 to the 8th power. That leaves 5. You're left with y prime equals minus 60 over 3x minus 5 to the 5th power. There you go. This is the same as that. This just is expressed with a negative exponent. So the only thing that you're going to have to watch out for is watch this exponent very carefully. If it's negative, that minus a 1, it becomes more negative. Notice we went from minus 4 to minus 5. Here we kept it in we left it as is, the denominator. When we took this g prime, 4, that 4 came here, but 4 minus 1 is 3. So you just have to watch the signs. If it's positive, it goes down. If it's negative, it still goes down. It becomes further negative. That's really the only thing you have to watch out for. And again, you're going to make the mistake. I make the mistake. I still make the mistake after all these years. I mean, this is just the nature of the game. Again, we just have to be as vigilant as possible. Okay, so let's go ahead and go on here. Let's see. So now we have y equals this thing. Okay. Well, looks like we're going to have to just do quotient rule. So we'll just do quotient rule. So once again, recall quotient rule. It is, let me go back to red here. So quotient rule, y prime. So if this is f and this is g, we have g f prime minus fg prime over g squared. So let's see. So y prime, or dy dx, is equal to this times the derivative of that. So we have x cubed minus 3x minus 2 times the derivative of this, which is 2x, minus this, x squared minus 5 times the derivative of this, which is 3x squared minus 3, all over x cubed minus 3x minus 2 squared. We have to multiply all of this out on top. So y prime equals 2x and x cubed. That should be 2x to the 4th minus 6x squared minus 4x. Okay, this minus sign. X squared, 3x squared is 3x to the 4th. With a minus sign becomes minus 3x to the 4th. X squared minus 3, so this is minus 3x squared, minus a minus is plus 3x squared. This times this is minus 15x squared, so it's going to be a plus 15x squared. This is minus 5 times minus 3 is plus 15, so it's minus 15 all over x cubed minus 3x minus 2 squared, and then we put it together. 2x to the 4th minus 3x to the 4th, that takes care of these. We get a minus x to the 4th minus 6x squared plus 3x squared is minus 3x squared plus 15x squared, so we get a plus 12x squared, and then we have minus 4x, and then we have our minus 15 all over x cubed minus 3x minus 2. That is y prime, or dy dx. There you go. Whenever you're dealing with quotient rule, as we get into more and more complex functions, trigonometric functions and things like that, exponentials, you're going to notice that the quotient rule, the biggest problem is going to be, where do I stop simplifying? So again, it's up to your teacher what they want. Sometimes they'll just ask you to stop right there and just leave it like that. Other times they'll ask you to simplify as much as possible. Personal choice. The mathematics itself, the important part is being able to recognize the f and the g and to keep the order straight. That's what matters. Okay. Okay, so suppose that u and x and v of x are functions that are differentiable at x equals 0. And you know what, I think I'll actually work in blue here. And that u of 0 equals 7, u prime of 0 equals negative 2, v of 0 equals negative 3, v prime of 0 equals 2. Find the values of the following at x equals 0. So here we're going to form the derivatives and then just use these values, plug them in. Okay, so let's start with d dx of uv. Well, d dx of uv, well, that's equal to u prime v plus u v prime. Well, u prime is negative 2, v is negative 3. Again, this is all at 0. Plus u at 0, which is 7, times v prime, which is 2. So this is 6 plus 14 equals 20. I don't even need to know what the functions are. I know what the values of the functions are and their derivatives. So the rest is just actually very, very simple. Good. Okay, so let's do, so the dx of u over v. Well, the ddx of u over v is v u prime minus u v prime over v squared. V is negative 3, u prime is negative 2, minus u, which is 7, times v prime, which is 2, over v squared. V is minus 3 squared. So you get 6 minus 14 all over 9. 6 minus 14, I think, is negative 8. So you get negative 8 over 9. Good. So we have ddx of, this time we have v over u. Well, this is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. Plug the values in. We're going to get 7 times 2 minus a minus 3 times minus 2 all over 7 squared. That's going to equal 14 minus 6 all over 49. That equals 8 over 49. Good. Now we have ddx of 5v minus 4u. Well, that's 5v prime. The derivative of this is just the constant times the derivative of this. That's just v prime minus 4 times u prime equals 5 times 2 minus 4 times negative 2 equals 10 plus 8 equals 18. And then our final one, ddx, almost the final one, sorry about that, ddx of u to the 4th power. U is a function of x. It's equal to 4 times u cubed times du dx, which is u prime. So we have 4 times 7 cubed times minus 2. We end up with minus 2,744. And now we actually have our final one, ddx of 7v to the minus 3. Well, v is a function of x, so this becomes 7 times negative 3 times v to the minus 4, negative 3 minus 1 is minus 4, times dv dx, which is v prime. V is a function of x, so we have to multiply by v prime. That's the rule for powers. So this becomes minus 21 over v to the 4th. I just went ahead and put the negative 4 down there, times v prime. That equals minus 21 over minus 3 to the 4th times 2, and you end up getting a final answer of minus 42 over 81 if I have done my arithmetic correctly. Hope that made sense. Okay. Let's see. Example number 7. oops, I got an extra page there. Find an equation for the tangent to the curve x squared over x cubed plus 3 at x equals 2. Very, very simple. We find the derivative. We put the value 2 into that derivative. That gives us the slope. We find the point, the y value, and then we just form the equation. So let's go ahead and start with y prime. Let's see. So y prime equals this times the derivative. So this is f, this is g. This times the derivative of that minus that times the derivative of this over this squared. So we have x cubed plus 3 times the derivative of this, which is 2x, minus x squared times the derivative of this, which is 3x squared, all over x cubed plus 3 squared. So y prime is equal to 2x to the 4th plus 6x squared minus 3x to the 4th all over x cubed plus 3 squared. Y prime at 2. So when I put 2 into this, I end up with minus 16 plus 24 over 121. I end up with 8 over 121. This is going to be our slope. It's going to be the slope of our line. The derivative at the given point is the slope of the tangent line through that point, through the x value of that point. Now, so the slope is equal to 8 over 121. Now let's find f of 2. We need to find the y value. So the f of 2, that's just going to be 2 squared over 2 cubed plus 3, which is going to be 4 over 11. So our point is 2 and 4/11. Therefore, our equation is y minus 4/11 equals 8 over 121 times x minus 2. There you go. They wanted the equation of the tangent to the curve at x equals 2. When x equals 2, the y value is 4/11, so we know the line passes through that point. The slope of the line is the derivative at that point. Y minus y1 equals m times x minus x1. Okay. Okay, so let's see here. X squared over x minus 7. Find d squared y dx squared. We need to differentiate this twice. Okay, let's start with y prime. This is f, this is g, so it's this times the derivative of that, which is going to be x minus 7 times 2x minus x squared times the derivative of that, which is 1, all over x minus 7 squared. This is going to equal 2x squared minus 14x minus x squared all over x minus 7 squared. Therefore, we have a final answer of y prime is equal to 2x squared minus x squared. That's just equal to x squared minus 14x all over x minus 7 squared. Okay. So, now we need to find y double prime, which means we differentiate this. So let me rewrite this as, so y prime is equal to x squared minus 14x. I can do this either via quotient rule again, or I can do the product rule. So I'm just going to go ahead and rewrite this as x minus 7 to the negative 2 power. I just brought it up, and I'm going to do this as a product rule instead. So y double prime, which is the derivative of this. Okay, now we have, so let's go to black here. This is our f, and this is our g. Our g is actually this whole thing. But notice that g itself is made up of a function raised to a power. So I just have to be really, really careful here. So this is the power rule. I'm sorry, this is the product rule. This is f times g. So we're going to have f prime g plus fg prime. The derivative of this times that plus the derivative of this times that. Okay, so f prime is equal to 2x times g, which is x minus 7 to the minus 2 power, plus f is equal to x squared minus 14x times the derivative of g prime. Well, the derivative of this whole thing is minus 2 times x minus 7 to the minus 3 power times the derivative of what's in here, which is just 1. So now I simplify. I'm going to write this as 2x over x minus 7 squared plus, this is minus, I'm sorry, this is going to end up being a minus, minus 2 times x squared minus 14x. I'm going to bring this thing down into the denominator. I'm going to write it as x minus 7 cubed. Hope that makes sense. The negative 2 and this thing stay on top. I just brought this down. Now I'm going to find a common denominator here by multiplying the top and the bottom by x minus 7 because I want the denominator to be x minus 7 cubed. So this equals 2x times x minus 7 minus 2 times x squared minus 14x all over the common denominator, which is x minus 7 cubed. 2x squared minus 14x minus 2x squared plus 28x x minus 7 cubed. 2x squared minus 2x squared, they go away. Minus 14 plus 28, I'm left with 14x on top, and I'm left with x minus 7 cubed on the bottom. This is my y double prime. Here was my y prime, my first derivative. Here is my second derivative. Okay, now I'm going to do this again, but this time I'm going to use the quotient rule instead of the power rule so that you see, well, just for the sake of seeing another path. So let's go ahead and write y prime again. So y prime, that was equal to x squared minus 14x all over x minus 7 squared. Now I'm going to take the derivative of this. So so y double prime equals this times the derivative of that, x minus 7 squared times the derivative of this, which is 2x, minus that times the derivative of that, x squared minus 14x times the derivative of this, which is 2 times x minus 7 to the 1 power times the derivative of what's inside, which is 1, over x minus 7 squared. Okay, that's going to equal, I'm going to multiply it all out, x squared minus 14x plus 49 times 2x minus 2 times, I'm going to multiply these all out. The x squared minus 14x times the x minus 7. I pulled the 2 out, brought it here. This is going to be x cubed minus 7x squared minus 14x squared plus 98x all over x minus 7 squared. Oh, I'm sorry, x minus 7 squared squared. So this is going to be to the 4th power. My apologies. There you go. I'm telling you. Vigilance is the most important thing in calculus. Okay, so let me see. What have we got? So let's go ahead and let's multiply these out. So we get, let me actually give myself a little bit more room here. 2x cubed minus 28x squared plus 98x minus 2x cubed plus 14x squared plus 28x squared minus 196x all over x minus 7 to the 4th. 2x cubed goes with 2x cubed minus 28x squared plus 28x squared. I end up with 14x squared, 98x minus, this is going to be minus 98x all over x minus 7 to the 4th. I'm going to pull out a 14x, and I'm going to write that as x minus 7. This is x minus 7 to the 4th. This one cancels one of these. I'm left with 14x over x minus 7 cubed. So it's absolutely your choice. You can either go product rule, you can go quotient rule. You're going to end up with the same answer. One of them is more tedious, usually, than the other. And in this particular case, it looks like the quotient rule was actually the one that is more tedious. Okay, so I hope that helped a little bit. Thank you so much for joining us here at Educator.com. We'll see you next time. Bye-bye.